Okay, this first topic that we're discussing now is about complex number. But in detail, we anticipate a little bit in the other class complex number. But now in detail. Okay, cool. Complex number. Okay. Suppose I want or I need to compute square root negative one number. 25, I select 25 because 25 is nice. Because 25 is perfect square number. No? So I want to prove that this is no real solution. It's the first thing I need to do. Okay, real. What mean real? Real is a line in one dimension, like that. Horizontal line or real number. Okay, it's extending from positive infinity. Remember, infinity is a symbol to indicate a huge number, and negative infinity. In the middle is 0. Now we have 1, 2, 3, 4, 5, and so on. 6, 7, 5. 5 is a good candidate to be solution because according to the definition, 1, 2, 3, 4, and negative 5, according to the definition of the square roots, a square root of any number, I need to find one number can multiply by itself, give me a number inside the bracket. However, if I fail, because 5, see, I pick 5, divided by 5 is positive 25. No, negative 25, because the thing I need. And negative 5 also fail because negative 5 times negative 5 is positive 25. Well, okay, no secret. The problem is that the solution of this is not on this line. It's in another dimension. It's in another dimension. By the way, this dimension is perpendicular to this. But it's not important now. The important is that for solving that problem, it's clear that it's not real, mathematicians create by definition a square root negative 1 is equal I. This is symbolic way to indicate. And this is called unitary unit. Imaginary unit. Unitary unit is the same stupid thing. It is imaginary unit. But likewise, que 1 is a real unit. I is imaginary unit. By definition. So far, we have two kinds of number. Imaginary. The number que contain I and the number que do not contain I. The number que contain I is real, and the number que contain I is imaginary. This is just a name. Historical name. Because imaginary is no science fiction, it's no ghost. It's another kind of number. That's it. Okay? So now, well, if you create this symbolic way to indicate that number, the solution for the square root negative 25, que es the problem at the beginning, is equal square root 25 positive multiplication by square root negative 1. Entonces, square root 25 is 5, and square root negative 1 by definition is I. And the answer is 5i. Okay? Okay, so what's the formula, professor? The formula is easy. Square root any negative number, compute the square root of the positive number, same multiplication by I. This is my formula. Another example, of course, we are doing several examples. Suppose that was example 1, and this is example 2. Square root negative 200. Oh, again, negative number inside the square root is, you compute the square root positive 200 and multiplication by I. And see, the number is positive, no, it's real, the solution. And 200, you break it down like a 2 and 100. And the square root 2 is, leave it like that, square root 2, because it's a prime number, but 100 is 10. The answer is 10. And the answer is 10 I radical 2. It doesn't matter the order. The order, you write the 3 elements. The 10 is this, I is this, and radical 2 is this. I don't know why the elegant way to do this is in this order, but I know important. I know the ordering is correct. Okay, you get the idea? Any questions so far? Okay. No? You can interrupt me if you want. You ask me any question. I want to complicate your life a little bit, not too much. Suppose square root negative 9 times square root negative 9. I put 2. Okay, the typical mistake is put together, try to join, and only one radical. Negative 9 times negative 9. This is wrong. It's wrong. Why? It's wrong. The reason is clear. Immediately you see negative number inside the square root is imaginary. So this number is imaginary and this number is imaginary. Okay, entonces it's easy because the square root negative 9 is square root positive 9 times I. And I know very well that square root positive 9 is 3. It's 3i. The answer of this guy is 3i, and the answer of this guy is also 3i. So 3i times 3i. Es obvio que 3 times 3 is 9, and I times I is I squared. And leave it like that? No. Why no? Because I squared, unbelievable, is equal to negative 1. I want to prove. I want to emphasize, notice one new idea. Okay. You remember that the definition of the I is square root negative 1. If you square both sides, and so we have I squared equal, and you know very well the square power and square root cancel out each other on those, each other is equal to negative 1. Wow. So what's the answer, professor? The answer is negative 9. The answer of the example 3 is real. Okay, you pass through the process of the complex number, but the final answer is negative 9, and negative 9 is real number. Okay, so now, to understand a little bit much better, the, Professor, can you speak louder into the microphone because, okay, Professor, can you speak louder into the microphone because, okay, I put the volume in the 50 units. I put more, much better now? Much better now? Much better now? Let me know. Yes, Sophia. Okay, Sophia. Okay, the thing I try. Okay, so the confusing part is now, if you multiply I times I, it's I squared. The I squared is negative 1. Wow. Okay. Remember again, repetition. This is my all real number line. Try here. Okay, this is all real number line. 90 degree. Cool. Okay, this is all real number line. This is the real numbers. Okay, this is infinity positive, this is infinity negative, 0 in the middle. To the right we have positive number, to the left we have negative number. This is 1, this is 2, this is 3. This is negative 1, this is negative 2, and this is negative 3. You know very well that. Now, we have the imaginary, but where is located the imaginary? Well, the imaginary is located perpendicular to this. I want to prove why. The imaginary is located perpendicular to this. Okay, exactly this. Okay. Well, I try to do my best, passing through 0. So this axis, this new axis, is the imaginary number. See, this is 0, and this is 1, but actually no 1 is I. This is 2I, and so 3I. This is the imaginary axis. And likewise, the bar down is negative I, is minus 2I, and so on. Minus 3. Okay? Look, when you multiply the effect, if you multiply by I something is, you know, rotate 90 degree. When you multiply by I, multiply by I, the effect, let me see the effect. Suppose one like a vector like that, boom, boom, 1. However, if you multiply by I, the effect is 1 times I is I. So the effect is, wow, rotate 90 degree. This angle is 90 degree. Let me make a zoom to understand much better. However, see I, you multiply by I again, okay, the effect of the multiplication by I is rotate 90 degree. I prove somehow que es negative 1. Entonces, I rotate one more time, by 90 degree. So I rotate 90 degree, another 90 degree. Okay, this is the reason. Suppose que I multiply again, I times negative 1 is negative I. And negative I is exactly on the imaginary, but down. This is negative I. So when you multiply by I, our complex number, our number, real, rotate 90 degree. We start at the beginning with the 1, multiply by I is I. There's a light on the imaginary axis. When you multiply by I, the second time, I times I is negative 1, light in the real axis. When you multiply negative 1 times I, is negative I, is here on the imaginary axis. And finally, negative I multiply again by I. So the thing I'm doing in this process is always multiplication by I. I prove geometrically que rotate 90 degree is negative I squared. But I know very, very well que I squared is negative 1, so it's positive 1. Because it's negative 1 and another, but let me explain in detail. This is negative, and I squared is negative 1, and double negative becomes positive. And we come back again to this. So basically, the thing I try to explain is, we have two axes, the real number axis, okay, we know in your life, in the entire life, and we have another new axis que es perpendicular, okay, get the imaginary numbers, and it's forming here a complex plane, complex plane, two-dimension complex plane. Okay, for real number is one dimension field. Imaginary number is one dimension field, but together form a complex plane, and we can express it any complex number like a linear combination of the imaginary and real. Okay. Now, let me condense the information. I is I square, rotate 90 degree and negative 1. I cubic, rotate 90 degree again and negative 1. And I to the 4 is positive 1. Wow, important information. Do you understand very well or no? I promise in a few seconds, we come back again to this idea. And we study any power. Any power, right? Do you understand or no? Or confused? Very confused, eh? Yes or no? Now let me see.
Professor, I have a question.
Go ahead.
Uh, when you rotate the line 90 degrees when multiplying by I, that rotation will always be against the clockwise.
Yeah.
Okay.
See, yeah, clockwise.
Okay.
No, clockwise.
Against against the
Counterclockwise.
okay.
Yeah, it's a technical name where when you specify rotation, say clockwise or counterclockwise. Yes, it's
Okay.
counterclockwise, miss. Yeah,
Okay.
yeah.
Thank you.
Okay, let's continue. Let's continue with the example. Because I little bit deviation to the power of I, but we cover after, I promise. Suppose example number 4. Example number 4, typical example you see in the test. Suppose you have this, compute that. Square root negative 64 times square root negative 25. Okay, entonces immediately you see that the square root, o sea, negative numbers, sorry, inside the square root, you understand que es imaginary solution. Entonces es super easy. You compute it one by one separately, never joined. It's a mistake because negative and negative positive. Entonces you lost the information of the imaginary number. And this is a square root 64, que es 8, and I, que represent the imaginary number. Likewise, this is 5i. And together is ai multiplication by 5i, que 40, 40i squared. But I know very well can never you leave it like that, the answer, because I squared is real. I squared, you need to know que I squared is negative 1. Therefore, the final answer is minus 40. Done. End the story. Clear? Super clear or super confusing?
Professor, so you got 40i squared from multiplying 8i and 5i?
Say again, you write 40i times I, like that?
Yeah, I said, did you get 8i and 5i by, did you like multiply them to get 40i squared?
Yeah.
Oh,
But the thing I try to explain, this answer is correct, but it's incomplete. Because I suppose that you need to know that I square is real. But when you indicate I, it's because you want to get the idea about imaginary number. But the problem is that I square is no, it's not real. It's not imaginary. Sorry, it's real. Okay, do you see or no? In the complex plane, I square is the green arrow, negative 1, because you rotate 90 degree 2 times, 180 degree. Make sense or no?
yes.
Okay. So you leave it like that, 40i squared. It's correct, but incomplete. So now, maybe in my test on paper, I give the credit or partial grade, but Alex, no, Alex don't understand. Alex is a robot. And Alex say, no, this is wrong. Because Alex wants, okay, you write the answer like a minus 40. Okay, supposing the square root negative 16 times square root negative 4 times square root negative 40. 9 power 3 square root. And inside, we have negative number. It's easy. You compute it one by one separately. Never join, never mistake, big mistake. This is for I, this is 2i, and this is 7i. Yes or no? Now you copy multiplication 4i times 2i times 7i. And you multiply 4 times 2 is 8. 8 times 7 is 56. I cubed, because we have 3i. And leave it like that. Well, it's correct, but it's incomplete. Because I need to know that I cubic is negative I. Because in this case, you rotate 3 times 90 degrees. Now the vector is located at 270 degrees. O sea, it's on the imaginary part, but down. Entonces, actually, I need to know by memory maybe que I cubic is equal minus I. And the final answer, correct, is minus 56i. That number is purely imaginary, but it's negative. Make sense? Make sense? All right, yes, Sophia. Okay, Sophia. One more example, similar to this. Yes, the last one. Okay. Example 6. Okay, is square root negative 36 times square root negative 81 times square root negative 16 times square root negative 9. I promise que one important question in the test is this. I put several square root and contain negative number. And you need to know that you cannot put together never, so you compute separately one by one. And after, this is 6i, this is 9i, this is 4i, and this is 3i. And you put together 6i times 9i times 4i times 3i. And do multiplication. 54 times 4 times 12 is 648. Remember, we can use a calculator anytime. The arithmetic part is not important for me. Actually, it's mandatory using calculator. Okay, because in the other chapters, we are using a special function that is impossible to compute by hand. So we need mandatory calculator. What kind? Scientific calculator? No, super expensive, no, cheaper. But contain a logarithmic function, exponential function. And we have I to the 4th power. Because we have 1, 2, 3, and 4i. And leave it like that? No. Well, it is correct, but it's incomplete. You need to know that I to the 4th power is 1, positive 1. Because you rotate 90 degrees 4 times, and 90 degree multiplication by 4 is 360, and 360 degree stay the same, in the same real axis positive direction. Look. You rotate one time, we go from the real axis to imaginary positive. So you rotate again, so you multiply again, sorry, by I, you have in the real axis one more time, by the negative direction. You multiply the 3rd time by I again, we have in the real axis in the negative direction here. And finally, so you multiply by 4i, we come back at the beginning. So we have again on the real axis in the positive direction. Some people memorize this, not necessarily. So one geometric interpretation of this idea is this plane. Si you don't like this, no problem. You don't like, You memorize this, and that's it. It's easy. Entonces, we come back again. We study now in detail. In detail now. Detail, super detail. Super detail now. Power of I. So we discuss in detail how we compute power. Power of I. Power of I. Of course, in this moment, I want to discussing using only positive exponent. After I promise you, we discuss a negative exponent. I know very well. Ki is I. I squared is -1. I cubic is negative I, I to the 4th power is positive 1. The challenge now is determine the any power. I to the 5th, the 6, the 7, the 8, the 9, the 10, 11, and 12. And any, bang, 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 bang. I discovered the formula. I discovered the algorithm to find any power of I. Well, using intuition, I to the 5th power, get the next. It's obvious que es I to the 4 times I. So one more time, we multiply by I. One more time, you rotate 90 degrees. Es obvio que si I to the 4 es 1, 1 is invisible multiplier, and the answer is just I. Wow, it's exactly the same of this. Intentional, I put in the same row. Row 1 or row 0. 1, 2, and row 3. This is the organization I propose. Column 0. Yeah, I know by memory. I know by memory this column. The thing I try to explain is the rest. Column 1, column 2, column 3, and so on. When I discovered at least the first row, or row 0, sorry, is I. It's obvious que when you multiply by I, it's -1. It's negative I, and it's positive 1. So this is a perfect coincidence, and we continue. This is I, -1, negative I, and positive 1. Entonces now, what is the challenge, Professor? One of the challenges is, suppose you have a big number, no? 15, 18, 20, 45. What is the shortcut? What is the thing to find super fast? Okay, let me try to explain intuition and one shortcut. Suppose now I want to compute I to the 15. By the way, I to the 15 is the next column 3, I suppose. But it's okay, no, I not do two things. I want go to a specific 15. So I try to find the multiple of 4 close to 15 down. Oh, guess 12. So for exact multiple of 4 is 4, is 8, is 12, is 16, is 20, 24. Entonces, I break it down 15 and I to the 12, que es the multiple of 4, exact multiple for close to 15, but down. Not up, because up involve negative exponent. I don't want to complicate my life, only down. Multiply by I to the 3rd, right? Because 12 plus 3 is 15. You know very, very well that any exact multiple of 4 is 1, and 1 is invisible multiply. Therefore, the answer is I cubic, and the I cube is negative. This is the way, intuition. Therefore, si you continue, this is I 13, it's I 14, is -1, 15, wow, is negative I. Negative. And 16 is obvious, Okay, 1 positive, because any exact multiple for S1, E1 is invisible. But okay. I understand, Professor. However, I have a shortcut to do this idea super fast. You take 15. You divide by hand by 4. Why by 4? Because this partner is repeated 4 by 4. 4, 4, 4, and 4. And when you divide by 4, this is 3. 3 times 4 is 12. Subtraction, remember, division is multiplication and subtraction. And the answer is 3. Okay, so what means that 3? That 3 means the column. Column 3. Look at that. The 15 belong to the column 3. And this 3 is a coincidence. You see another example, no. Belong to the row. Row 2. Row 2. One more. One less than. Row 2. Oh, you forgot this. Okay, the shortcut to do super fast. You forgot this. This is not important. I don't care too much the row. I care the column, sorry. I care the row. The row is, entonces es I to the 15. 115 is equivalent to I cubic. Where come from this 3? This is the 3. Remainder. Y I know by memory the column 0. Y I know que I cubic is negative. Final answer. Negative. Do you understand, or I explain too complicated, or I explain too weird, or not good? Let's do an example. I have 1, 2, 3 more examples. And we continue after. But this is the final answer. The final answer is negative. I15 is negative. Suppose I to the 18. So 18 is the next, I suppose it's the next column, but I don't care too much this. I in one corner of the piece of paper, I copy 18 divided by 4. Always divided by 4. Because the partner is repeated, 4 by 4. Cyclical by 4. Now it's obvious que es 4, because 4 times 4 is 16, subtraction is 2. Oh, yeah, I don't care that 4. I care the remainder. This is I squared. Yeah, I know very well, because I know by memory, okay, I squared is negative 1. End the story. Do you follow me? Do you follow me? Do you follow me? Answer.
Yes.
Okay. Suppose 2 more examples. I to the 20. You take 20, divided by 4, always by 4. Fi times 4 is 20, remainder is 0. I take the remainder, I20 is equal I to the 0. You need to know by memory that any number raised to the 0 power is equal 1. And this is classic, it's clear, because 20 is exact multiple of 4, and the answer that we expect is 1. Okay, in the column 4, for example, we have I to the 17. Let me erase that part. 17 is I, 18 is negative 1, 19 is negative I, and 20 is 1. It's expecting because it's 20 is exact multiple of 4. Any power of I exact multiple of 4, the answer is 1. Okay, I to the 9. Oh, I to the 9 I saw here. I have this, but suppose I have not this table, and it's too long to do the table. The shortcut is clear. You divide 9 divided by 4. It's 2, 8, subtraction 1. It's I to the 1, it's just I. Final answer. Any question? Everything okay? Are you clear in the power of I? It's a typical question. This is a typical question, guys. I put arbitrary power, and you divided by 4, take the remainder, only remember the column 0, and that's it. Super easy. Okay, now let's move on. So you have no more question. To the complex number. What is that? What is a complex? You need to know terminology. Complex numbers. Okay, what is that? Well, complex number is a combination. It's a number. It's a number que we formed by a combination real number and imaginary. Example to understand more clear. Complex number. Okay, you have, for example, 4 plus 3. Oh, this number is a combination. 4 que represent the real part and 3i que represent the imaginary part. Okay. So in conclusion, complex is a combination of the real part that we study in our entire life and the imaginary number that we study today, no? Okay, and this is, so we have maybe a special cases. For example, 4 alone is purely real because the imaginary part is 0. That you can write if you want 4 plus 0i. And for example, 3i alone is purely imaginary. And you can write if you want, not necessary, 0 plus 3i. Because the format to write a complex number is the standard format or standard form of the right the complex number is you write first the real part and secondly the imaginary part. Okay, you need to respect this. This is the style of algebra. Okay, so we study now in this topic operations, arithmetic operation using complex number: addition, subtraction, multiplication, division, right? And this is very, very important, extremely important. Suppose the first operation que we study is a conjugate. What is that? Conjugate. Sound familiar? Conjugate. Conjugate, suppose 4 plus 3i, again, the same example. But you put the bar here at the top, okay, indicate conjugate. This bar indicate conjugate. And the conjugate is too easy. You copy exactly the same, but you change the sign only for the imaginary part. Repetition. The conjugate of the one complex number is that you take the real part exactly the same, copy and paste. But the imaginary part, you change the sign. Okay? So you want to see, for example, the graphic representation of the complex number of the conjugate. This is the real axis. You copy the fancy R and the fancy imaginary axis. And 4, 1, 2, 3, 4 is the real part. And the imaginary part is 3, 1, 2, 3. This is 3i. This is 4. Okay, you put together. Okay, this is the point. Normally, you indicate like a vector, like that. Include arrow. This is the geometry representation of that complex number in the complex field, in the complex plane. However, the thing I try to explain now is a conjugate interpretation. The conjugate is you change the sign of the imaginary part minus 3i. Therefore, the conjugate is like that. Okay, you like create the image and the real part. that the real part behave like a mirror, and the second. And I promise that we're using this idea in the division part. Okay, conjugate. Okay, let's do it now. Addition and subtraction gets super, super, super easy. Addition. Addition to complex numbers. Suppose this elementary example. 4 plus 3i again, I like this number, plus 2 minus I. So basically, you have complex number 1 plus complex number 2. Now, each complex number contains real part and imaginary part. Okay, you remove the parentheses always, 4 plus 3i plus 2 minus I. And you manipulate like light terms. So you adding the real part and you adding the imaginary part, or subtracting, depending on the sign. So 4 plus 2 is 6, and 3 positive minus 1 is 2. And it's my final answer. Cool, easy. Now subtraction. Well, subtraction is similar, except in the subtraction, that's always happen. You have minus n and subtract. For the same number or another, this is not important. The important is the procedure. You remove the parentheses. So you copy 4 plus 3i. But now be careful, because in the minus n and the subtract, sorry, you change the sign. So this minus in the front change completely the thing. That change completely the complex number in the subtract. It's minus 2 plus I. And one more time, you combine real, imaginary. Lighter. So it's 4 minus 2 is 2. And 3i positive and 1i positive is 4i. Subtraction. Any question? It's very, very straightforward. Now, multiplication, I want to complicate a little bit. Not too much, but multiplication is a little bit more complicated. Multiplication. Multiplication is, well, you multiply two complex numbers. Suppose again the same number, 4 plus 3i times 2 minus I. But this is time. So now, you know, multiplication is the arithmetic operation. Okay, not necessarily you put a symbol, because default, see, you enclose the number in between parentheses, you understand it's time. And when you multiply to binomial, you know very well the thing you should do always is FOIL. To treat the complex number like a binomial, because the complex number have two parts, real part and imaginary part. And you FOIL. 4 times 2 is 8. 4 times minus I is minus 4i. 3i times 2 is 6i. And 3i times minus I is minus 3i squared. You understand very well this operation? And leave it like that? No. Why no? Because you combine later. So first of all, you need to remember that I squared is equal to -1. So I squared is not imaginary. I squared is real. Therefore, you replace I squared for -1. And double negative becomes positive. So 8 minus 4i plus 6i plus 3. The shortcut is you replace automatic in your mind. I squared for -1. And see, in the front we have a negative, another negative, together is positive. And now ready to combine. Real, 11. Imaginary. Well, this is negative 4 and positive 6 at subtraction is 2. Do you understand very well multiplication? Do you understand very well multiplication? And don't forget, so you write your final answer using I squared. This is totally incomplete. However, I want to take advantage of that moment to explain one particular special example of the multiplication. Okay, got it. I want to take advantage to explain one particular example of multiplication. So in this case, I am doing multiplication again, but in this scenario, we are doing the multiplication two complex numbers. The relationship between them is a conjugate. So I know very well that 4 plus 3i conjugate is 4 minus 3i. 4 minus 3i conjugate 4 plus 3i, because the action of this hat of this conjugate is change the sign of the imaginary part. But now we are doing the multiplication in this example of two complex numbers that they are conjugate each other. Now you see surprise. I don't know anything. So you are always you can apply for anytime. However, I want to explain the super quick FOIL in this particular example in which you have conjugate. Okay, I don't know anything. I try to do my best. I multiply 4 times 4, 16. I multiply 4 times minus 3 is minus 12. I multiply 3i times 4 is positive 12. Wow, look at that, always happening in the multiplication of the conjugate. Wow, okay, the imaginary part have the same value and the opposite signs. And finally, last is minus 3 I squared. Wow, look at that. Always happen until 100%. Disappear. That part, the imaginary part. Conclusion, the answer of the multiplication two conjugate complex number is real, never I, no I anymore. Because I know very, very well. Okay, sorry, I made a mistake here. It's 3 squared. 3 times 3 is 9. And 9. Okay, one more time happen. Okay, you mentally replace I squared for negative 1. And double negative together become positive. So the answer is 16 plus 9, 25. Okay, two important conclusions. Conclusion number 1. When you multiply, this is a special, very important, a special product. When you multiply any complex number times is conjugate, the answer, unbelievable, is real. No I anymore. It's a conclusion number 1. And conclusion number 2 is you multiply the first. In this case, 4 times 4, 16. And you multiply the last. In this case, 3 times 3 gets 9. I don't care si it's positive or negative, always is positive, and I disappear because I squared is negative 1. And you adding this 16 is 25. This is a shortcut to do this in 1 second. Okay, so you don't remember the shortcut, no problem, I understand. You apply for anytime and you get the same answer. This is a shortcut. And this shortcut is important because we are doing in division. In division, we are doing this. A ver. I need help. Suppose you multiply 2 plus I and 2 minus I. Who help me? Who there? Let's do it, for example, 1, 2, 1, 2. 1, 2. Another example is 1 plus 3i, 1 minus 3i. So you are aware that this is special, no? Because it's the multiplication two complex numbers que they are conjugate. No? So the professor explained the only thing you should do is multiplication. One more example. Multiplication first and last. Suppose 1 plus I times 1 minus I. And this 1, 2, 3 example is the typical example in which you are doing multiplication two complex numbers, but they are family, they are conjugate, right? And it's special. What is the answer? So the answer we expect is real. And the answer we expect is just the multiplication first and last. Because I know very, very well the inner and outer cancel out always. That is a reason que the answer is real. Who helped me in the number one? What's the answer number one? Come on, participation. Guys?
5.
5, no? 5? Who say
Yes,
Elsa,
5.
no?
5.
5. Where come from this 5, Elsa? Come on, explain me. Or explain us.
Oh, because you multiply 2 by 2 is 4, so the I by I is I square, and that's minus 1. So yeah, it's minus 1. So when, oh no, it's not 5. It's 3.
Yeah, 5. You're right. The shortcut to
Oh
do
yeah,
so.
because the minus at the front of the I converts the one in positive. Yes.
Exactly,
So it's 5.
exactly. Okay, one more fast idea. Look, you multiply 2 times 2, and you multiply coefficients here, que es 1, and coefficients here, que es 1. Well, a negative 1 actually, pero I don't care because always is plus.
Okay.
And the magic is always is plus is because I square together with another negative become positive. This final answer is 5. Exactly, you predict at the beginning. Another participation, no, Elisa, no? You're Elisa, no? Miss?
No, Gloria.
Gloria.
Yes.
Okay, another participation, come on. Then number 2.
Number 2 is 10.
10.
Is 1 plus 1 is 1, and 3i.
1 plus 1, no.
Multiply. 1 times 1. Yes. Sorry.
One,
And 3i is 9. And 1 plus 9 is 10.
Super. What about you are? What's your name?
Elsa.
What is your Elsa? Okay, Elsa. Elsa always good student. Now number 3, another participation. No, Elsa? No.
I can help with number 3.
What is the answer number 3, Mister?
It's 1 minus I plus I minus I to the square.
What is the answer then? Remember. Remember. The answer I need, I know, is a real number. Because it's a special multiplication. When you multiply any complex number times its conjugate, the answer is 1 real number. And you want to do a step by step, no problem, I understand. But what's the answer? Is my question. And you
I don't have the answer yet.
No? Okay, no problem. Thinking. Another participation. Come on. 1 plus I times 1 minus I. Easy. Piece of cake. Come on. A ver, I have a lot of stuff. Daniel, Fernando, Sofía, Apolinario, I want to hear your voice. Tú, Apolinario dice, es tú. Es tú, Apolinario is right. Why tú, Apolinario? Explain me. You have microphone or no? Or using the chat, Apolinario? Typing. Apolinario?
Yes.
Yes.
Because we multiply 1 times 1 is 1, so the complex number multiplied by negative it's square, so negative, yes.
Something like that?
Yes, it's like that.
Cool. You are the best. My internet is very unstable, Professor. Sophia, okay, you need to fix this. Remember to take class online. Some people take class online. No online, sino en this modality que es NDC Live. So you have no good computer, you have no good internet connection, then you cannot take online class. It's obvious, no? You take in person, that's it. So you need to fix it. Go to the internet provider company, see that situation. So you understand very well the multiplication or no?
Yes.
Okay, let's move on to division. Division. Pay attention. Now division. Division complex number. You divide, for example, 4 plus 3i divided by 2 minus I. So we have one complex number in the top divided by another complex number in the bottom. Okay. Focusing. Now, to do this, the only possibility you have is this is the original problem is given and you modify a little bit, include one. It's a classical. Always include one smart one. Smart one can help me to simplification that. And this smart one is created using the conjugate of the complex number in the denominator part. It's 2 plus I. And you put 2 plus I. You know very well that any expression divided by itself is 1. And this is a smart one. And this smart one help me to simplify the thing. Okay? Now let's do it. But you understand the basic idea? Okay. So now, suppose, let's do the multiplication. The multiplication, this guy times this guy. They are not shortcut because they are totally different family. You multiply 4 times 2 is 8. 4 times I is 4i. 3i times 2 is 6. 3i times I is 3i squared. So far, everyone follow me? In my mind, immediately, I never write I squared because I know very, very well that I squared -1, I change the sign as -3. So instead of positive 3i squared, in my mind, I don't waste the time doing this. It's -3 because I know very well that I squared is -1. So we continue the top part. 8 minus 3 is 5. This is the real part. And the imaginary part is 4i and 6i is 10. Cool. I did the top part. Now the bottom part is super easy because they are conjugate. Yeah, I know very well the shortcut. The professor explained. Can you multiply 2 times 2 is 4. Always plus, never negative. The coefficient and the imaginary part is 1. Okay, fine. You follow me? You follow me? You're lost?
Yes. No, lost. I follow you.
Okay.
Following.
Now, okay. Now. Okay, yes. Anika. No, you leave it like that. No, never. You split this common denominator. 5 divided by 5 is the real part. And then I divided by 5 is obvious. Okay, 5 divided by 5 is 1. And divided by 5 is 2. Boom, final answer. Beautiful final answer. Okay, in conclusion, division look like a little bit, no loss, a little bit complicated, a little bit, because you need to create a smart one. The smart one is formed by the conjugate of the complex number and the denominator of the hour division. Now, S is 1. This 1 doesn't affect the final answer. However, open the door to understand. You multiply the top part, FOIL, and multiply the bottom part, non necessary FOIL, quick FOIL, the shortcut. The student don't remember, no problema. You are doing by the classical FOIL always, and that's it. This was the example 1. Example 2 is 10 divided by 1 plus 3i. Wow, professor, this is weird. No, it's not weird. In this case, you are doing the division, and 10 is a real number. You know, real number is a particular case of the complex. And the imaginary part is 0, but no necessary specification. This no, hello. And the 1 plus 3i gives is a complex actually. This is the given original. What should I do? Create the smart one. And the smart one is doing or is created using the conjugate of the complex number and the denominator gets 1 minus 3. Okay, I need help. Okay, let's do it first, the top part. Who help me with the top part? Is FOIL or is distributive property? Because it's a monomial. Look, 10 is only 1, guys, not binomial. Multiplied by binomial, entonces you apply distributive, ¿no? 10 times 1, este. 10 times 3 is 30, minus 30. Okay, now here special multiplication. What is the answer of this special? 1 plus 3i times 1 minus 3i. What is that? What is the answer here?
1 plus 9.
1 plus 9. 1 plus 9 is?
10.
10. Now finally split. 10 divided by 10. Minus 30i. 30i, sorry. Divided by 10. 10 divided by 10 is over 1. And 30 divided by 10 is 3i. Final answer. Right, this problem. It's really easy. One more. Division. Example 3 of division. I need help. 4a plus 4i divided by 6 minus 9i. You guide me. The arithmetic operation I am doing. You guide me. You say, what is the first thing you should do? What is the first thing?
Smart one.
Smart one. And a smart one, who help me with the smart one? What is that?
It's the same number but with different sign in the denominator.
Entonces 6 plus 9i. Like that?
Yes.
It's okay?
Yes.
Cool. Now let's do a multiplication. Multiplication of of the top part is complicated always because there are no family. If there are no family, you apply FOIL to multiply. 8 times 6 is 54. 48, sorry. 48. 8 times 9, 54. I, because contain I. 4I times 624. I. And 4I times 36, right? If actually it's 36I squared. But in my mind, I know que I squared negative 1, entonces minus 36. I recommend que automatically you replace I squared for negative 1 and you have 36. Cool? Okay, we continue manipulate the top part and you combine real is 48 minus 36 is 12, positive 12. And imaginary together is 54 plus 24 is 96. Okay, I did the top part. And the bottom part is super easy. Who helped me with the bottom part? This is special. And special remembers first and last. And don't hesitate.
36 plus 81.
Exactly. 36, where come from 36? What the multiplication 6 times 6? And 81, where come from is 9 times 9. I don't care that one guy is positive and one guy is negative, because always the answer is positive. Because remember, we have in middle of the process, 1I squared, to change the sign. And this is 170. Okay. And I split 2 over 117 plus 96 over 117I. Okay, we can reduce in lowest term divided by 3 is 4 over 39 plus 32 over 39. Okay, always you, okay, you leave it like that. Me, it's okay, but Alex, no. Alex, you have to, the final answer is possible, reduce in lowest term. And you detect, wow, 117 is divisible by 3, no? And 12 is divisible by 3. Okay. And 117 is divisible by 3, and 96 is divisible by 3. Remember the shortcut to understand quickly, okay, one number is divisible by 3. Suppose 117. Bueno, you put in the calculator, hello. However, when shortcut you add in the digit, 1 plus 1 plus 7 is 9. And see, this number, the answer is this number, belong to the 3 multiplication table, that's divisible. And 96, 15 is all divisible by 3. 12 is obvious. Any question? No? Super. Okay, so now this is a moment now to understand, to explain again the power of I. We see before, power of I, but using negative exponent. Negative exponent. Sometimes in the test you see positive exponent or negative exponent. Negative exponent. Let me write this exponent. Power of I again, pero use a negative exponent. Entonces now suppose one elementary example, example 1, I do negative 9 exponent. And you need to remember que negative exponent is reciprocal. You see negative exponent, you flip it. This is 1 over I to the 9. You remember that? The next positive, there fire alarm going off the building. Wow. Okay. Okay, Grace. fire alarm. Okay, this is the beauty of the online class. No? We have in different. We have one place gets in trouble. You have to go. Okay, now, well, does I focus in I to the 9. It's easy because I did exactly the same that we are doing before when this positive exponent, no? I take 9 divided by 4, 2 es a subtraction of 1. Oh, entonces I to the 9 is equivalent to the 1i. I to the 1 power, you know, the exponent is 1, this 1 gets a remainder, it's a 1, but when this exponent 1 is invisible. You follow me so far?
Yes.
Okay, now we have in this moment in front of the one problem of the division. So actually, you divide 1, gets a real number, divided by I, gets it pure imaginary. No? So 1 is 1 plus 0i, is pure real, and I is 0 plus 1i, is pure imaginary. And the professor explained me, for doing the division, we create the smart one. And the smart one is formed by the conjugate. What is the conjugate of I? Well, it's 0 minus 1i. No? Actually, it's negative I. You copy negative I here, and negative I here. Do you follow me? So the conjugate of I is negative I. And now multiplication. Multiplication, top, bottom, bottom. 1 times negative I is negative I. And the bottom we have negative I squared. Or I squared is negative 1. That's negative I divided by negative 1. So the negative become positive 1. The answer is negative I over 1, que es negative. Super. Clear or confused? Example 2. Suppose I to the negative 13. Compute that. What should I do? What should I do? What should I do? What should I do? The negative exponent. Come on, participation. I know that you are shy. No? Good participation. Manika, Tara, Elsa, Gloria. Come on, guy. What should I do? What should I do? Emily. Emily say in the chat. Reciprocal. Emily suggest me in the chat. Change the negative exponent to positive. Okay. After that, what should I do with the 13, guys? I don't remember very well. How we compute I to the 13?
Divided 13 with the 4.
Okay, suppose que es 3, right? It's 12.
Yes, 3, 12. So you have
So this is 1 over I.
over I, yes.
Yeah, but I did before. I don't want to repeat again. Example 1 ending in the same part.
Yes.
After you
minus
I skip that step is negative. That's unbelievable. The reciprocal of I is negative. This is the property important. Okay, one more easy. Example 3 is I to the negative 11. What should I do?
turn it into a reciprocal?
Now 11 divided by 4, no?
Yes.
Yeah, I suppose que 2 because 3 is too much. It's 8, remainder 3. Okay, it's 1 over I cube. But I know que I cube is negative I, right? So you replace 1 over negative I. Now it's a crucial moment que you multiply, it's a classical division. You multiply by the conjugate. The conjugate of negative I in my mind is 0 minus 1I. And the conjugate is change the sign of the imaginary part is 0 plus 1I, entonces es I. The conjugate is I. And you multiply 1 times I is I. I did this multiplication before. Es negative I squared, que es positive 1. The answer is positive I, end the story. Cool?
I have a question about
Right.
the 4, how we divide by 4. Is 4 gonna be like a constant thing, or is it always gonna be 4 that we divide by?
Yeah, remember the partner of the power of the I is 4 by 4. Do you remember this sketch I did before? The column, the row. Do you remember or no?
Yeah, I remember.
So this is 4 by 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If you want to locate one specific guys, example this, using another column, you divide by 4. And the 4 gives you the column. And the remainder give you the row que es located this. And you take the row. It's the remainder. Okay, the column is not important. It's totally irrelevant. You remember? So this is
Yeah.
This is cyclical. It's a cyclical. So always you divide by 4. Look, divided by 4, divided by 4, and divided by 4. Any other question?
No, but thank you for answering my question.
Oh no, it's my pleasure. My pleasure. I enjoy it. See, you are doing a smart question like that. Okay, now let's move on to the any power of I. Power of any complex number. In this topic, we raise to the second power, to the third power, any complex number. I bring two examples because sometimes if the power is bigger than 2, 3, 4, this is too long. Let's just FOIL several times. Let's do an example, 2 examples. Example 1 is easy. Suppose que I have 2 plus 3i squared. It's a power. Square power. Second power. So this is a cubic power, so it's too long. You need to multiply. But since this is second power, you multiply 2 plus 3i. Time is 7. And you FOIL. Two times 2 is 4. 2 times 3i is 6i. 3i times 2, 6i. And this is 9i squared again minus 9, right? Do you like this way? Can I put directly? Another possibility is you put 3 times 3 is 9, I squared. And I know very well, I squared is -1, it's real. Therefore, I skip this step. I put directly. Cool. Notice, in the conjugate case, that part is cancelled. But in this case, no conjugate, it's the twin brothers. It's exactly the same addition, twice. So the answer is -5. You combine and imaginary is 12. What else? Super. Okay. Another example. Very, very confusing. Suppose radical 2 over 2 plus I radical 2 square. Well, in this case, I put the irrational number. You say, Professor, why you put a weird number? Well, no, I put a weird number because I want to verify one. So now square copy radical 2 over 2 I radical 2 over 2 times 7. Somebody want to ask me something? Put the microphone off. Microphone putting off. Cool. Okay. Entonces you, wow. But this is easy because any number is the same. Like when you multiply radical 2 over 2, let me put it here. 7 times is 7. Radical 2 and radical 2 times radical 2 is radical 4. And radical 4 is 2. And 2 times 2 is 4. When you reduce and always start at 1/2. So any multiplication here, give me 1/2, 1/2, 1/2 using I or 1/2 without I. For example, this and this is 1/2. This and this is 1/2 again, I. Because include that I. And this is again 1/2 I. But this and this is 1/2 again, but negative 1/2 because it's I square. And it's I square in my mind, I replace by -1. Okay, now ready? Real part and real part together disappear, cancel out, 0. And 1/2 plus 1/2 is 1. Wow, entonces what is the answer? The answer is just I. 1/2 plus 1/2 is 1I. The answer, unbelievable, is just I. Okay? Like if you multiply this complex number times itself, give me I. Wow, it does it's because, wow, look at that interesting thing. It's because square root I is radical 2 over 2 plus I radical 2 over 2. Because the thing I am doing was the verification backward by this number by itself and give me I. Therefore, the square root I. But this is very, very complicated doing. And when you take trigonometric, guys, if you want to take trigonometric, stay with me next semester in the spring. Trigonometric is Mac 1114. Mac 1114 is trigonometric. And in trigonometric, we study in detail how we manipulate the power of this root, sorry, and the square root. Square root and any root of the complex number. And the one efficiency way. Okay, so we have 4 minutes. 4 minutes, I propose you one problem that maybe we don't finish. However, spending for the next time. Okay, look, suppose case given, if it's a compound problem that involves everything. If I define Z like 3 minus 4i and W like 8 plus 3i. I need to compute please for me. Number one, C plus C hat. Number two, W minus W hat. Remember, hat is a representation, symbolic representation for the conjugate. Number three, C times C hat. And number four is C minus W hat. Okay, let's do it. Number one is you adding C, que es 3 minus 4i, plus the conjugate, que the conjugate is 3 plus 4i. Remember conjugate, so the conjugate of C would be 3 plus 4i. Now you change the sign of the imaginary part, and W hat is A minus 3i, I guess so. When you remove the parenthesis, you know, when you remove the parenthesis, you have 3 minus 4i, 3 plus 4i, no? Wow, amazing, I like that. The imaginary part is gone, and we have 6. Boom, final answer, 6. 6 is the final answer. W minus W hot. Let me try to do this as the last one. We're pending 3 and 4 next time. So W is A minus 3i. Subtraction. Conjugate is A. No, this is plus, sorry. The original plus. Yeah. Minus 3i. Says A plus 3i. Say plus 3i. In this case, the part is gone, but the real part, and it stays 6i. Wow, amazing. We continue next time, guys. 3 and number 4. Okay, the time is over. We continue. In a few minutes, I will send to you the video of this lecture. Okay, have a nice day. Bye bye. I have another class now.
Thank you, Professor. Have a nice day.
Bye.